Hey guys, so this is my fourth attempt at videoing this, so hopefully it'll work. Okay, so as I said, as I said a lot of times before, my name is Whine, and today with Memphis Communiversity, and today we're going to be talking about integrals as limit sums. So as always, the worksheet and answers are linked in the description, so make sure to grab those and follow along so you guys can do it with me. So first I'm going to talk about the hypothetical theoretical reasons why we are going to be doing what we're doing. So if you don't understand what I'm talking about all of this, you really don't have to. You just have to learn the steps and do them, but I'm going to attempt to explain why we're doing what we're doing. So a limit sum is not essentially, it is a right Riemann sum. If you don't know what a Riemann sum is, we do have a video worksheet on Riemann sums, so make sure to go check that out. I'm not sure who does it, but I'm sure it is great. So a Riemann sum, for a quick refresher, is basically estimating an integral or the area under a curve by creating a bunch of rectangles and adding up the area of all those rectangles. As you can see, I drew a nice little picture right here demonstrating what it is. So a limit sum, our goal is to find the area between the function between a and b, these 2 points or any 2 points, using rectangles of the same length. I know I didn't draw them all the same length as in base length. All of these lengths are supposed to be the same. I'm sorry I didn't draw it that way, but they're supposed to be. So to find the area of any rectangle, as you guys know, we need the base and the height of the rectangle. So let's start with the base. The base might be a little bit easier to explain. The base is b minus a over n. It's also called delta x. That's what I'm going to be referring to it as in the rest of the video is delta x. But anyway, delta x, or the base, is b minus a over n, meaning b minus a, so this whole length, divided by the number of rectangles. So that hopefully makes sense because all of the rectangles have the same base length. So if you just divide the whole thing by the number of rectangles, it should be the base. Height's a little bit harder to explain just because the height fluctuates with the function. But so the height, also known as xi, I use the variable I in all of my examples in the video, but I've also seen k and j a lot. So xi or xj or xk, they all mean the same thing, but I just use I. So the height formula is a plus delta x times I. Quick explanation. So a is all this stuff back here, and then you add delta x to it. So right here is a plus delta x. And in this case, the I would be 1, so it would denote where this right top point is of the rectangle, and that gives us the height so that we can find the area of the rectangle. As you can see, I changes with every rectangle. Eventually, there are going to be so many rectangles that we can't actually count them, and we just use the variable I. Okay, so now I'm going to move on to the steps of how to do these limit sum problems. We're going to be we're going to be doing both the limit to the integral and the integral to the limit. We're going to start with integral to the limit on the worksheet and with the steps, but I'll explain both right now. Sorry, I'm going super fast. So when we're going from an integral to a limit, you're given an integral and you're supposed to write a limit sum of it. The first step we're going to do is find delta x, which hopefully, as you guys remember, is the base of that rectangle, and it is also b minus a over n. In this case, we know b and a, they're the endpoints of the integral, so we can actually solve for delta x, 6 minus 5 over n, 2 minus 4 over n, 6 minus negative 4 over n. N is just, we don't know how many rectangles there are going to be so many, so we actually just leave n as n, we don't plug anything in for it, so it's going to be a number over n. Secondly, we're going to find xi, which as you guys remember is the height, a plus delta x times I. We know a from the integral, we just found delta x, and then you literally just tag I onto it, the letter I, we don't plug anything in for it, it's just I. Next, we're going to plug in xi into the equation to make f of xi. So basically, there's an equation inside that integral, of course, and wherever there are an x's, not including dx, we're going to plug in xi to make f of xi. And then finally, step 4, we're going to multiply the base times the height. So f of xi times delta x. And then finally, we're going to create that limit sum, just basically putting it in the correct format with the limit and the summation sign, and that'll be your answer. Moving on, now we're going to go from limit to integral. Let me slide this over so you guys can see. I'll move my face. So limit to integral, it's basically working backwards because you'll have the limit and then you're going to actually try and write the integral that it came from. So first you're going to find delta x. In the first case you had b and a, but in this case you're actually just going to have delta x. As you can see right here, it's kind of tagged on to the end of f of xi, so it should be pretty easy to see. So you're just going to locate and spot that delta x. Then you're going to find a, which is also pretty easy to see because it's added to delta x times I in the f of xi. So it should be pretty easy to spot as well. And then once you have delta x and a, you're going to try and find b, which should be pretty simple because it's just this handy dandy equation right here. Once we have that, we're going to try and actually find the function that should go inside that integral. Remember when we were going from an integral to a limit, you plugged in xi wherever there was an x, and this is going to be the exact opposite. Wherever there's xi, you're going to plug in an x. This can be kind of confusing. It can be kind of hard to see the equation, but it's still very doable, and you just have to remember what you're looking for, and yeah. And then once you have the equation and the endpoints, it's time to create an integral, and you write the integral, and that is how you do it. I don't have these steps written out anywhere else in the video, so if you want to take a screenshot, I would recommend doing it. Here's the limit to the integral, here's the integral to the limit, and I'm going to follow all these steps in every problem, but I just thought it would be easier maybe if you had all the steps written out so you can remember what each step is as I'm doing them. It might be helpful. Okay, I'm going to keep going because I'm worried my computer is going to glitch again. Okay, so we're going to start with number 1. So we're going to write, we're going to write the following definite integral as a limit. So first step, we're going to find delta x, which is b minus a over n. Remember, it's just those endpoints. B is on the top, a is on the bottom. And remember, n is just a variable. We don't plug anything in for it, so it's 4 over n. Next, we're going to do step number 2, which is finding xi, which, as you guys remember, hopefully is a plus delta x times I. A should be pretty easy to spot. Remember, it's just the bottom, delta x we just found, and you literally just tag I onto it. Remember to be conscious of the negative. Sometimes they can be confusing. Now we plug in xi to wherever that x is in the equation. So in this case, it's 6 times the xi. Step 4, remember we're going to multiply f of xi times delta x. So step 1 times step 3. So that's f of xi times delta x. And then finally, we're going to put that whole chunk into this correct limit sum format. So on the AP exam, limit sums will mostly, if you are watching this for the AP course, limit sums will mostly be tested in the multiple choice section. What will be tested is not the correct format, so not the limit or the summation sign. Those things won't change. What will be tested is the delta x or the xi. So you do have to know the formula just to be able to, or the format just to be able to write this out, but it's not the most important thing of the question. The most important thing is everything that comes after the summation sign. Okay, we're going to move on to number 2 now. Okay, number 2. So we're going to just do the exact same thing. Sorry if you can see my slider a bit at the top. So as you guys can see, we just do b minus a over n again. Sometimes they're nice and a is 0. Make it a little easier. Secondly, we're going to do xi, which, as you guys hopefully remember as well, is a plus delta x times I. I wrote 0 plus just to maintain the format of xi. You definitely don't have to. And then you plug in xi wherever an x is in the function. In this case, it's x squared minus 10, so it's going to be 0 plus 3 over n squared times 10, or minus 10. And then you're going to multiply that f of xi times delta x, so step 1 times step 3, or step 3 times step 1. I go in that order. I'm just going to speed up my writing a little bit. If you ever need to pause and copy something down, don't be shy. A lot of this is super repetitive, and it's just a bunch of writing the same things over and over again, so it's kind of hard to explain everything just because it's so repetitive sometimes. So there's that limit sum. Remember, the format stays the same. What really just changes is after that summation sign. So as I said, when I was explaining the steps to the limit sum to the integral, which is the back side of this page, you're going to be given this, and sometimes seeing the equation that you're supposed to pull out of that can be difficult. So I recommend taking a second on each of these and like reminding yourself where the equation is, that this is really just subbed for x, and being able to identify that, because you will have to do that on the back of the worksheet. Okay, number 3. So once again, we're just doing the exact same thing. So we find delta x, and once again, I'm going to speed through my writing just because it's a bunch of writing, because it's the exact same thing, but feel free to pause and copy anything down if you need to. We find xi, which is a plus delta x times I. Number 3, we're going to find f of xi. If there are multiple x's in the equation, don't freak out, just plug it in for both, or however many x's there are. It's not that big of a deal. And then we are going to multiply that f of xi times delta x. So step 3 times step 1. And then finally, we're just going to stick it in that limit sum equation, or limit sum format. Remember, the format stays the same. The limit of x goes to infinity, summation sign, and on the top, whatever variable you choose equals 1. On the bottom, I always choose I. And that is your answer. All right, number 4. Remember, once again, to be careful with those negatives. They can be confusing. And always remember to include that negative of the a in the xi if the a is negative. We just plug in, now we're on step 3, we plug in that xi into x. Don't be freaked out that it's in a square root. No matter what the equation is, you just plug it right on in. And then we're going to multiply that f of xi times delta x. And then finally, we're going to stick that in the limit sum format. Sorry if my face gets in the way, I'll move it. Cool. All right. Last one, going from integral to limit sum. Once again, we're finding delta x. Be cautious of those negatives. Number 2, or step 2, we're finding xi, a plus delta x times I. Hopefully you guys are kind of getting a little bit of the hang of this by now. Plug in that xi wherever an x is. Don't be freaked out that it's in a exponent. Doesn't matter, you just plug it in wherever it is. I'm writing step 4 now. It's kind of tucked under the screencast thing, but I think I move it up so you guys can see it. There you go. And then finally, we're going to plug that number 4 into the limit sum format. So as you can see, this is very repetitive, very systematic, and should be pretty easy to get a hang of. Alright, so now we are doing limits to integrals. So you guys can see. Okay. Let me rewind. Okay, I'll leave it there. So, like I said in the steps when I was explaining them all at the beginning, this does kind of go backwards as to what the steps were in going from integral to limit sum. So you first have to find delta x again, but remember we don't know b and a yet, but we do know just the whole quantity of delta x. It's usually sitting by its lonesome, so 8 over n, 3 over n right here, 2 over n right here. It's usually very isolated, it's usually pretty easy to see. So we isolate that delta x, and then we find a. A is also pretty easy to see usually. It's just tagged on to the delta x times I inside your xi. So it's usually pretty easy to see. 5, -2, -6 is usually just lopped on. And then once you have your a and your delta x, you can solve for b. Using that equation delta x equals b minus a over n. In this case, b equals 13. Step number 4, we have to identify xi, and then identify what equation that xi was plugged into. So in this case, xi, hopefully as you guys can see, is 5 plus 8i over n. And then if you guys can squint and look and see, hopefully, my hand's out of the way, you can see the equation that this xi was plugged into. And in this case, it's x squared. It's xi squared, and then this is delta x, so it's actually not part of the original equation, remember? It's just lopped on the end. So, yeah. And this n minus 1 up here doesn't matter, by the way. Just don't stress about that. You just do it the same way either way. And so now we're moving on to number 5, which is actually creating that integral. B is on the top, a is on the bottom, and then just plugging in that equation that we found times dx. And that is the answer. So hopefully not too bad. They don't get much more complicated than that. Alright, so let's start it all over. Delta x, remember we don't know b and a yet, but we can just identify it. It's kind of lopped on, just 3 over n. A is usually pretty easy to find too. It's just lopped on the end of xi, which in this case is, and in this case a is -2. So now we can solve for b, because b minus a over n equals delta x. Once again, keep in mind the negatives can be tricky sometimes. Alright, and now we're going to try and identify what exactly xi was plugged into. We find xi first, which hopefully you guys can see. Excuse me. So hopefully you guys can see that in this case, once my hand gets out of the way, oh, rats. Xi is plugged into the square root of 8x plus x squared. Because as you can see, xi is just plugged into, xi is just this massive, I don't know, placeholder of x. And you guys can see that. And then finally, we just write that integral using b and a that we found, and then the equation. Cool beans. All right, number 8. doing the exact same thing. In this problem is the first problem. There's a different variable besides I. It actually uses j this time. Not a huge deal. As you guys remember, delta x is kind of lopped on the end, and a is lopped on the end of xi. So those two are pretty easy to identify a lot of the time. So then we're going to get to b by using that delta x equals b minus a over n. And then we're going to try and identify xi and then what exactly equation it was plugged into. And as I said, they use j in this case, but it's not a big deal at all. And as you guys can hopefully see, xi was plugged into -4 secant x. And now we're just going to use those endpoints that we found in that equation that we found and plug it into an integral, and that's the answer. All right, number 9. So once again, delta x. As you can see, it is put in front of the summation sign this time. It's right here. But that's not a big deal. It's still just the summation of f of xi times delta x. Is just in a different order this time. And oh yeah, a, hopefully you guys can see that a equals 0 this time, because there's nothing really added or subtracted from this delta x times I right here, 9i over n. So you can just assume that it's 0. Like I said on the front side of the page, I wrote 0 plus just to keep the format, but in a real question, you're probably not going to see that. So just keep in mind, if there's nothing there, it's 0. And then once we know delta x and a, it's pretty easy to find n, or find b, excuse me. And then we're going to identify xi and what equation it's plugged into. In this case, hopefully you guys can see that it's plugged into x to the 4th. I can't see what it says. Minus 6x plus 3. Just wherever that 9i over n is, you just plug in an x. And then once you have the BA and the equation, you can create an integral, and you get your answer. Cool. All right, number 10. In this case, it uses k instead of I. Not a big deal, though. So delta x, as you can see, it's 1 over n. A is 7, or is it? A is actually not 7. And here's why. So as you wrote down, delta x is 1 over n, but if you look what that 7 is attached to, it's 2k over n, so that is not delta x. So we have to identify what, and it turns out that a is actually 0, and I'm going to explain that in just a second. I think I write something out to help simplify it. So I'm actually going to rewrite this whole thing and help clarify why delta x is actually, or why a is actually 0. So once again, it's that limit summation equation, but we have to figure out why that is not delta x and where delta x actually is in this equation. Oh, it's okay, there we go. Okay, so this is what this equation is written out long form. So we knew something was sketchy because this is not delta x. So that must mean that that 2 that is on top of n is actually part of the equation. It's not part of delta x or part of the limit sum. It's part of the equation that we're actually going to plug in the integral. So we have to figure out where is our a and where is our delta x. So it actually, in this case, is it's ln of 7 plus 2 times the whole thing of delta x. And they just simplify this a little, and they cut out the 0 because it's a 0, and then they multiplied this k over n times 2, so the 2 ended up on the numerator, which some people could believe is the delta x, but it's actually 2 times delta x. So just really keep in mind to make sure that the delta x on the end and then the delta x inside of the f of xi matches up, because sometimes they can be tricky and do this, and it can be very confusing, and when a is 0, things can get confusing sometimes like that. Just keep that in mind. Now that we have the correctly, or not, they're both correct, but now that we have the easier form of the limit sum to look at, this will be pretty easy. So now that we know a is 0, sorry, I wrote b over there. We can find b equals 1, of course, and we have to identify f of xi, or xi now, which we found which also equals xk at this point, which we found to be 0 plus k over n. I wrote out the 1 just to make it simple. And then finally, we are going to, oh, actually, we have to figure out what the equation is. So this is plugged into, hopefully you guys can see, ln of 7 plus 2x. This 2 is actually part of the equation. It is not part of the xi, or delta x. Cool, and that is your answer. Last one, guys. We can do it. Okay, I'll just leave myself up there. I guess it's kind of out of the way. Okay, so step 1. This looks a little different than what we have been doing, but we can still do it. So we can still identify that delta x is 1 over n. It's just out here on its lonesome, so we know that. We can still kind of identify a because there's nothing added on to any of these guys, which are the different parts of the xi, and there's nothing added on to them, so we can still kind of identify it as 0. There's nothing added to anything, so it's got to be 0. All right, and now that we have a and delta x, we can actually still find b. But when we try to identify xi and like what equation this is plugged into, that's where this kind of gets kind of confusing. Sorry, I want to make sure you guys can see. Okay, so all of this stuff, you actually notice that there's no summation sign in this question. So we actually have to write out the summation. And we can do that. It's pretty easy. We got this. So first we notice that there's nothing added on. So a is 0. And then we have to figure out what is, sorry, I'll just let myself write it out, I guess. Okay, so where does I play into this, you might be asking. So we notice that all of these are going up pretty, like 1, 2, 3, 4, they're going up by 1. So there's nothing on the top of this fraction that would, there's no constant that would cause it to shift any more than 1. So it's just I. And then n stays the bottom, n stays the same on the bottom. So nothing's wrong with n. So we realize that, and we know that delta x is 1 over n. So this is just 1 times I over n. So that's actually our summation thing. And I forgot to, I'll write it in a second, but I forgot it. But there's actually a 4 to the 4th right here because everything's to the 4th. So I'll actually write it in right now, and then I'll write it in a second. So there's a 4 right there because all of it, because of these. That's the equation that this xi is plugged into, is actually x to the 4th. But first we found xi, and then we realized that it's plugged into x to the 4th still. Sorry, yeah, there I write that 4. So this thing looked really different, but actually it's kind of the same. It's not too hard. We figured it out, right? So whenever you're learning about, I guess, like summations or series, I think, question mark, you'll learn how to kind of identify how to write out these summations. But this one was pretty simple. Hopefully, you can kind of see where everything came from. Most of the time, like on the AP exam and on most of your exams probably, they will have this summation sign. This is just kind of one example that you'll see occasionally, so I wanted to include a practice problem. Here is the integral that defines it, and we are actually done, guys. So I'm glad this thing finally recorded. I hope this was helpful. I'm sorry if I sped through it a little bit. If you have any questions, be sure to drop them in the comments and we will get back to you. Thank you for watching, and keep watching more Memphis Communiversity videos. Happy mathing.